2 of learning about equations and solving equations is going to be looking at a few simple equation examples that are just the skills, not bringing any real life problems into these situations. So our first example is 5 plus p equals 15. So we're going to want to solve for p. We need to isolate the p. In order to isolate the p, we're going to have to subtract this 5. If I subtract the 5 from one side, I must subtract the 5 from the other side so that we keep the same value on the two sides of the equal sign. Well, 5 minus 5 is 0, and 0 plus p is going to be just p. On this side over here, I have 15 minus 5. 15 minus 5 is 10. So I have solved for the variable p equals 10. Another way to use some of our prior learning is thinking about fact families. If 5 plus p equals 15, then that means that p plus 5 equals 15. That did not help me solve for or isolate the p. However, when I do the other part of the fact family, we know this means 15 minus p equals 5, and 15 minus 5 equals p. Now you can see in this last fact, in our fact family, we have isolated the p. So fact families, and I'll write that over here, can help us in solving equations. So let's look at another example. Fact families. Okay, another example here is where we have two expressions connected by an equal sign. That means the value on both sides will be the same. So I'm going to begin by solving my numeric expression of 8 plus 7. 8 plus 7 equals 15. 15 equals 5 plus x. So another way that we can isolate the x or thinking about solving would be to say 5 plus what equals 15? Well, 5 plus 10 equals 15. So that means x equals 10 because 10 plus 5 equals 15. This is how we have been trained to solve it in years past because we saw this as a box instead of a letter. And when we saw the box plus 5 equals 15, we knew it had to be the 10. Using our knowledge of basic facts to isolate the variable and solve for its value. Those are two examples when we're using addition or subtraction. Now let's look at some examples if we're using multiplication and division. First thing we have to remember is that if you have a number next to a variable, it means to multiply. You can see why it's not favorable to write the times sign, because now we have an x, and you have to ask yourself, is that the variable x? Do I have 9 times x times g, or do I have 9 times g? Well, because of above, we know this is actually 9 times g. I could have also written this as 9 and put the g in parentheses, meaning 9 times g. So if 9 times something equals 99, that means I have two options. I can divide both sides by 9, doing the inverse operation in order to solve for the variable. So 9 divided by 9 is 1. 1 times g is going to be g. 99 divided by 9 equals 11. So g equals 11. So another thing we can look at is our fact families. If I have 9 times g equals 99. I know G times 9 equals 99. I also know that this is the same as saying 99 equals G times 9. That's what we just said. So looking at the rest of the fact family, we're going to have to look at the inverse operation. So now let's look at the division part of this fact family. So I have 99 divided by G equals 9. And I also have 99 divided by 9 equals G. So I have now isolated my variable, isolated G. And this is where, right here, we said 99 divided by 9. So 99 divided by 9 equals 11. So G equals 11. Let's look at one more example. On this last example, I am only going to do the fact family. So what we have here is we have 56 divided by L equals 8. So that means 56 divided by 8 equals L. So 56 divided by 8 equals L is the same thing as saying L times 8 equals 56. What times 8? So in the past, we might have seen this as a box or a question mark. What times 8 equals 56? 7 times 8 equals 56. So L equals 7. So those are 4 different skill examples of solving equations.